All right, you guys, maybe the third time is a charm. This is going to be my third time trying to record this, so I'm trying to make it shorter. Um, this is a continuation of our notes from earlier today, notes 5.6, inverse trig derivatives. And what I want to do is continue on the backhand. Continue on the back of our worksheet this morning or this afternoon, and go ahead and finish that problem. And on a separate video, I'm going to do that bottom problem. All right, so of course, this problem that we had on the back of our worksheet today asked where are the points of inflection for the graph of y equals arctangent of x quantity squared. The key thing I want to point out here is points of inflection. We get our critical points from the first derivative, and we get points of inflection from the second derivative. So yes, we're going to have to take the second derivative of this problem. But to get there, we're going to have to first take the first derivative. So let's go ahead and do some u substitution. I'm going to let u equal arctangent. I'm noticing that arctangent arctangent of x is a function within a function. And due to the chart that we were using today, I know that the derivative of this is going to be 1 because the derivative of x is 1. 1 divided by 1 plus x squared. So let's go ahead and plug in these values into what would have been the original function, y equals u squared. Well, now I want y prime, which is going to be the derivative. And of course, we know that that's just simply going to be 2 times u du. Well, let's plug in what we know for u and du. I know that u is arctangent of x, and I know that du is 1 over 1 plus x squared. And to go ahead and multiply those two together, I get that y prime is simply 2 times arctangent of x divided by 1 plus x squared. So of course we're not done. We're going to have to take the derivative of this again in order for us to get to the second derivative. That means we need to take the derivative of this guy right here. And we're going to have to use a good old-fashioned quotient rule. So if you remember quotient rule, we had a little saying in class, the low d high minus high d low all over the low low, or the bottom squared. So that's pretty much what we are about to do. Let me separate and give me a line of demarcation. So y double prime would be the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. So now I want to see if I can clean this up a little bit. I'm noticing that this 1 plus x squared cancels out with that 1 plus x squared. Anything else? I don't think so. So my y double prime is simply 2 minus 4x times arctangent of x divided by 1 plus x squared squared. Now, remember that we are looking for when this equals 0. It's a rational function. The denominator is never going to give me my zeros. I don't really care about my denominator. It's all about the numerator. I want to know when is 2 minus 4x times arctangent of x equal to 0. And I do that by going into my calculator. You can use your TI 84, 83, 89, 91, or plug into your y equals this equation, or plug this equation in for your y equals. However, of course, you want to make sure that you use this inverse of tangent key, second tangent, into your calculator. And then use the second calc and zero function that we use in the classroom to find out where the zeros are. And once you do that, you will see very simply from the graph that x will equal plus or minus 0.765. And that is the answer. And so what we just found was at both of these points, our original graph is going to have a point of inflection or a change in concavity.